All right, we're on section 11.9 today, and I'm going to do some 3D graphing. So you need your notes, and this is a bit unique, so it might be a bit confusing. I'll do my best to explain it, and you might need to email me questions if you have them. So this is a three-dimensional graph, and it works a bit different. So this right here is positive x direction, and then this over here is positive in the y direction, and then this up here is positive in the z direction. So it's basically like this right here, the x and y, normally that we look at as vertical, has now been flipped so it's horizontal. And so this is supposed to look like kind of a T shape where you have a horizontal plane, which is your XY plane, intersected by a vertical plane, that's your Z. And so I don't know if that makes any sense at all. All right, so how do you graph? So this says graph a box with one corner on the origin and the opposite corner at 4, 7, -4. So the origin is right here. It's the point 0, 0, 0. And to graph the opposite corner, 4, 7, -4, you need to go 4 in the x direction, 1, 2, 3, 4. And then from this point, we go 7 in the y. So yeah, 1, 2, 3, 4, 5, 6, 7 in the y. And then from that point, you go 4 in the negative z direction. So from this point down, 4. 1, 2, 3, 4. So here's the point 4, 7, -4. So there's a difference there, right, in graphing from 2 dimensions to 3. In 3 dimensions, 4, 7, -4, it's not 4 in this direction, and then from here go to the 7 in y way over here, and then go to the -4. No, you go 4 in the x direction, and then from that point go 7 in the y direction, and then from that, 7 in the y direction, and then from that point 4 in the negative z direction. So here's 4 and 7, -4. Now we have to make a box out of this. And so we have 2 of the points for the box so far. And basically what the way to do this is my options for my x coordinate are 0 and 4. My options for my y coordinate are 0 and -7. And my options for the z coordinate are 0 or -4. And then you just fill out every possibility. So I can have 4, 7, 0, right? Because I had 4, 7, -4. I can have 4, 7, 0. Then I can do 4, 0, 0, 4, 0, -4. And then, so 4, 7, -4, 4, 7, 0, those are my 2 z options. 7 and 0 are my 2 y options. So I have those, and then my x options are 0 or 4. So I can either do, I have 0, 0, 0 already. So I can do 0, 7, -4. I can do 0, 0, -4. Then I can do 0, 7, 0. And I already did 0, 0, 0. That's the top one. So I have 1, 2, 3, 4, 5, 6, 7, 8. So those are the 8 vertices of my box. So here's what it's going to look like. So we already graphed 0, 0, 0 and 4, 7, -4. So now we graph 4, 7, 0. 4 in the x direction, 7 in the y. That's right here. And 0 in the z. So this point here is at 4, 7, 0. And now we have 4, 0, 0. So we just go 4 in the x direction, 1, 2, 3, 4, and then nowhere in the z, nowhere in the y. Sorry, nowhere in the y, nowhere in the z. Okay, so that's point 4, 0, 0. Now we have point 4, 0, -4. So 4, 0, and now -4 means we go down 4 from here. 1, 2, 3, 4. Okay. Now we do 0, 7, -4. So 0 in the x, but 7 in the y. Sorry, 7 in the y, which takes me out to here. And then -4 in the z. So that takes me to right here. So this is the point 0, 7, -4. And then 0, 0, -4. So 0 in the x, 0 in the y, and then 4 down. That's here. And then we have 0, 7, 0. So 0 in the x, 7 in the y, 0 in the z. Now, we have 2 different rectangles here. So so this one back here is the one in back. So I'm going to use a dashed line. And then this one here. And then across the y-axis. All right, and then you have the, I guess that one could have been solid. Sorry. Then you have here to here. And then this here. Then this here. This here. All right, so there's my box. Oh, I forgot this one here. Sorry, one more. Uno más. Okay, so there's my box. So here's the front. 4, 0, 0, 4, 7, 0, 4, 7, -4, and 4, 0, -4. I didn't write the point here. So basically the 4 points with 4 as the x-coordinate are the front, and then the 4 points with 0 as the x-coordinate are the ones in the back. So this point here was 0, 7, 0. So there's our box in 3 dimension. What is the 3D distance formula? So this is just like the 2D distance formula, except we have a z coordinate now. So x minus x1 plus, sorry, y minus y1, these are squared. Sorry, there's a plus sign here. Plus z minus z1 minus, oh my goodness. Oh, terrible. x1 minus x2, y1 minus y2, z1 minus z2 squared. I'm sorry. So that's really messy. x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. All right, so that's just like when we did the distance formula in 2 dimensions, but now we add the z. All right, find the length of the box diagonal. So let's draw the diagonal in, and you can go, so you're going from either rear corner to front, rear back corner to front up here, or you can go from bottom left to top back. Doesn't make a difference. I don't know which one's easier to see. Maybe we'll do this one. Oh, sure, why not? Okay, so that diagonal goes from the bottom of the front corner to the top of the back corner. And so the question is, what is that distance? So I have, we're going to use the distance formula. So we got 4 minus 0 squared plus 7 minus 0 squared plus 0 minus a -4. Gotta be careful with that one. So we end up with 4 minus 0 is 4, squared is 16. 7 squared is 49. And 0 plus 4 is 4, squared is 16 again. 16 and 16 is 32, plus 49 is 81. So D equals the square root of 81, so D is 9. Okay, so that's how to use the distance formula. Number 4, what is the equation for a sphere? So thinking back, and we did the equation for a circle, we looked at the distance formula, and we said we're really looking at what is the distance from any point on the circle to the center. And so we came up with this formula down here for the equation for a circle, where r is the radius and hk is the center. So for a sphere, it's the same idea. You're going to have r squared equals x minus h squared plus y minus k squared plus z minus j squared. So there's your equation for a sphere. All right, so let's just use this space down here and say, what if we had to find, let's just take an equation for a sphere. So if I have a center of 2, 4, 5, let's say, is the center of my sphere, and my radius is 3. and I say, find me some lattice points of this sphere. So the first thing you're going to do is you got to find the equation for the sphere. So you can hit pause and try to do this yourself, or you can watch me. So you get 3 squared equals x minus 2 squared plus y minus 4 squared plus z minus 5 squared. Okay, because this is my center, so it's just, this is h, this is k, this is j. It's a little trickier if we were to use negatives, but all right, now I want to find lattice points. So lattice points have to be integers, and so the strategy is the same. So we can just pick values, for example, for x and y, and then just make this equal to 9, 3 squared. So let me demonstrate. So if I pick x is 2 and y is 4, I'm doing that because 2 minus 2 is 0 and 0 squared is 0. And 4 minus 4 is 0, 0 squared is 0. So if I were to do the problem now, 3 squared is 2 minus 2 squared plus 4 minus 4 squared plus z minus 5 squared. So that would simplify. 9 equals 0 plus 0 is 0. 9 equals z minus 5 squared. Now I can solve that, right? Because I know that if I can get this to be 3 or negative 3, it's going to give me 9. So what minus 5 is 3? Well, 8, right? 8 minus 5 is 3. 3 squared is 9. I also could do 2, because 2 minus 5 is negative 3, and negative 3 squared is 9. So I can do 2, 4, 2. And that would be a lattice point. Then I can use the same strategy to find more. So I could keep 2 in for x. Now I can put a 5 in for z, right? Because 5 minus 5 is 0, 0 squared 0. And then I can just solve this to get 9. So I can do 7. 7 minus 4 is 3. 3 squared is 9. So 2, 7, 5. I also can do one where this is negative 3, so that would be 1. 1 minus 4 is negative 3 squared is 9. So, and then I can go and put a 4 in for y and a 5 in for z, and then I can find x values. So for example, 5 minus 2 is 3. 3 squared is 9. So 5, and then I can do it again, and this time I can put in a negative 1. Negative 1 minus 2 is negative 3. Negative 3 squared is 9. So that would work. So here are 6 lattice points that I can find quite easily. So you should be able to do that too. All right, again, if you have questions, let me know. Your homework is here for section 11.9. So hopefully it goes well.